Welcome to you all. Today we will try to explain the architecture of 806 microprocessor. Now, from the very first video, we can remember that we have explained the features of 806, where we have explained here that as per its architecture is concerned, it has two different parts. One is called BIU, another one is called EU. So today we will try to concentrate on this topic mainly. So let's get into the topic directly. So it has two parts in the architecture. One is BIU, that is bus interface unit, another one is execution unit, that is EU. Now this is the simplest block diagram I have tried to draw here. Hopefully you can find it. So this one. So this upper portion is called BIU, bus interface unit. So this region is basically BIU unit of 806 microprocessor, and the latter part, this one, is the execution unit, EU. So what are the features of BIU and what are the features of EU, and what is the function of these two different parts, and why they have been segregated into two different parts, everything will be explained here. Now we should remember that what is the function of BIU. So certain points are written here. That is very important. The circuit for physical address calculation is contained within BIU. So from the diagram you can find this is called adder. So this is basically the circuit which is required to compute physical address from two different addresses. One is called segment address, another one is called offset address. So in the upcoming video I will explain what is the function of segment address, what is offset address. So the actual physical address, that is 20-bit address, is calculated within this circuit, within this hardware, from segment address and offset address. That is the function of BIU. Another function is, that is very important function, is that it holds prefetch instruction queue. The length of this queue is 6 byte. So it has 6 byte prefetch instruction queue. From the diagram probably you can find it. Here this particular block represents prefetch queue whose length is 6 byte. And as the name suggests, bus interface unit. So this particular unit contains all the buses by which this processor basically communicates with the peripherals. So that means address bus, data bus, everything will be there, including the control bus also. So all the buses, all the signals will be here so that the processor can communicate with the outer world with its peripherals. Now, what is pipeline architecture? I will explain that one. Now, go into this one, that is EU, execution unit. So from the diagram you can find this area is called execution unit. So what is the function of this one? As the name suggests, it executes something. What it executes? It executes all the instructions that already fetched by the processor. So already we know an instruction is a combination of opcode and operand. Opcode means we are talking about that particular section of the instruction which defines the function that we want to perform with the help of this instruction. And what is operand? That defines on which the operation we want to perform. So the operation that we want to perform is called opcode, and the operation that we want to perform on a particular element is called operand. So in most of the cases, operand can be registers, the content of registers, memory locations, etc. So this is the internal structure of internal block of 806 microprocessor, which is responsible for execution of the opcodes mainly. And what it holds to do that? So obviously as it executes, as this is the executing part of the processor, so it should have a ALU, arithmetic logic unit. And we know that it's a 16-bit processor, so its word length is 16, so its ALU has to be a 16-bit one. So it has a 16-bit ALU. In the previous video we have talked about flag registers. So you can find that the flag 16-bit flag register is an inherent part of execution unit. Another thing is that decoding circuit. So it holds the decoding circuit also. This decoding circuit basically decodes the opcode. This opcode is initially stored within prefetch instruction queue, and I will explain that the combination of this prefetch instruction queue including BIU and EU makes this one, that is called pipeline architecture. So what it basically does, it is very simple. So whenever bus interface unit is busy, when bus interface unit is busy to communicate with the peripherals and fetches the instructions from the code segment memory mainly, because we know the memory in 8086 has been segmented into different parts. That particular segment which is used to store the program itself is called code segment memory. So code segment is that particular memory where the executable program is loaded. So whenever we want to execute that program, the instruction of this program has to be fetched into this prefetch instruction queue first, and to fetch that information from memory we need the help of buses, and already we know BIU is that unit which provides those kinds of buses. So by using all these buses and control signals from the code segment memory, the code or the opcode comes into this particular prefetch instruction queue. Now its size is 6 byte and its structure is FIFO, first in first out structure. So if we draw in this way, it can be like this one. So maybe like this one, it's a FIFO structure. So the first ever opcode that has been fetched by the processor will come out of the system, first in, first out. So maximum 6 different opcodes can be stored here, only if the size of the opcode is 1 byte. So the first question comes, why the length of this queue is 6 byte? The answer is very simple, because the largest instruction that 8086 has is of the length of 6 byte. So that is the length of the largest instruction, size of largest instruction of 8086 microprocessor. So suppose in a program which we want to execute by this processor, that might contain an instruction whose length is 6 byte. So to give the space to accommodate that particular opcode or that particular instruction, we need at least 6 byte size in the queue. So that is why the size of this queue is 6 byte. Now, so the function of the bus interface unit is to, by using its buses, it fetches the opcode that this execution unit wants to execute. So gradually from memory or from IO devices, mainly from memory, the opcode gradually comes into this opcode fetch queue, and the firstly fetched opcode will be transferred to this execution unit so that this unit can execute this opcode. Now whenever the execution unit is busy in executing the firstly fetched instruction by this queue, at that time what happens normally, this bus interface unit remains vacant or remains unused. So to increase the speed of execution, the developer has done something different. What is that? So whenever the firstly fetched opcode is being executed by the execution unit, at that time this prefetch instruction queue will be once again filled up by the next instruction available in the program that we want to execute. So that means the previously fetched opcode will be executed by EU section. So then what happens? The remaining 5 opcodes gets pushed in this direction, so the last location or the last byte of this queue becomes empty, and that empty location gets filled up by the bus interface unit with the next opcode that is available within the program. So what happens in this way, we can find there is not a single amount of time is available within the system during which the buses remains unused. So whenever we are describing about 8086, we assume that we have the certain amount of knowledge of 8086, 8085, and if we can recall the timing diagram of 8085, then the first machine cycle is always opcode fetch, and we know opcode fetch machine cycle requires 4 T-state. Now the first 3 T-state is required to fetch the opcode, and the T-state number 4 was used to decode the opcode that has been fetched by the system during this machine cycle. So during that particular period, the function of higher order address bus was unspecified. So here, to improve the speed of execution, what the developer has done is that whenever the execution unit is busy in executing the previously fetched opcode from the code segment memory, then bus interface unit fetches the nextly executable opcode that is available within the program, so that the combination of these two makes the system a little bit faster. And this section or this type of architecture is called pipeline architecture. So it is written in a very simple way. While opcode is fetched by BIU, the execution unit executes the previously fetched instruction. So that is the meaning of pipeline architecture. So you should remember, the pipeline architecture of 8086 is basically the combination of BIU and EU with the help of this prefetch instruction queue. And one more thing I should mention here, that beside this adder which converts the physical address, which converts or generates physical address from segment addresses and offset addresses, it holds the segment registers also. So the 4 segment registers including IP, that is instruction pointer, is the part of BIU, while these registers, that is AX, BX, CX, DX, and stack pointer, base pointer, SI and DI, source index, destination index, these are the parts of execution unit. So that is important and we need to remember. So that's all for the architecture of 8086. Thank you.